Hello everyone. So welcome back to our YouTube channel and let's start with another video of our Leetcode 75 days playlist. And today's question is longest subarray of ones after deleting one element. So we are given a binary array nums and we can delete only one element from it, and we have to return the size of the longest non-empty subarray containing only ones in the resulting array. And in case we have to return 0 if there is no such subarray. So if we can see this example, it is 1101 and the answer is 3. So it means that if we delete this 0, then we can get our 3 size subarray. And similar in this, so if we delete this, we have only this subarray of ones, and if we delete this, then we can have this subarray of ones. So our answer is 5. So let's just move to the intuition part to better understand this. Yeah, so we are given this example. The output is 5, which is on the basis that if we delete this 0, then our subarray is this one, which is of 5 size. Because if we delete this one, then maximum we have this. We cannot have this because it has 1 0. Similar, if we delete this, we can maximum have this size, this is 3. So the first approach that we can think of is if we can possibly delete this one. If we try to delete this one, and this will be now our array, and we try to generate subarrays with all ones. So it will be 3 first, it will be 2, and it will be 1. So we can store it in some answer that max of current answer and the previous. So we get 3, then we guess 2, it is not greater than this 3, then will not update it. Similar 1 will not update it. Now what we do, we just keep this 0 and okay, now we can earlier answer was 3. Okay, now we delete this 0. Okay, this 0. Now what will happen, our first subarray will be same this one, and sorry, this one, okay, and this one. So it is 5 and this is 1. 5 is greater than 3, so we'll update it. Okay, 5. Okay, now if we try to delete this one, now our subarray will be again this 3 size, this 3 size, okay, and it is not greater than 5, then we'll get an answer as 5. So this is a brute force approach. Okay, so let's just have a pseudo code for this brute force approach. What we'll do, we will run a loop for int I 0 to n. Okay, and we'll check if current I equals to 0. If it is 0, then what we'll do, we will pass this array in some variable. Okay, we will get our answer, get max. Okay, so we will create a function get max size subarray, something like this, and in the parameters we will pass this array, we will pass the size of this array and also current index I, so that we can skip it. Okay, this will get the maximum size of the subarray excluding this. Okay, excluding this ith element. So we'll get our answer, and now we'll update our answer equals to max of get max and answer. Okay, and with this approach we can get our answer. So it will be since, and this function will be, so we'll write function get max size subarray. It will have a array a, n and ith index. Okay, so what it will do, it will again, we will have current number of ones. Okay, which will be 0 current size and int max size, and we will again run a loop for int I equals to 0, I less than n, I plus plus. Okay, now what we'll do, we will go over this array again. Okay, so first, since we find this, we need to skip this. So what we'll do, we will write if I equals to, we will call it skip I or si. Okay, skip I, we will continue. Okay, and now if our array of I is equals to 1, that means that we have a current size. Okay, if it is 1, then what we have to do, we have to increase the size of the current subarray, and in case 0 comes, it means that we need to use this size. So if it is 1, that means we need to increment our current size, and else that means it is 0 because we have a binary array, right? So when it comes to else, it will do operation. Okay, so we'll update max equals to max of, we'll name it max size, or ठीक है, max of max size and current, and we'll update our current to 0, right? So this will be our function, and it will automatically, after this for loop, it will return max size. Okay, so this is our function. So the time complexity for this approach is big of n square, and space complexity is big of 1. Okay, since we, for this for loop, we are calling this function, and this function is again have a for loop. So for in for, this is big of n square, right? And space complexity is big of 1, since we are just using variables. Okay, so now the interviewer will ask to improvise on the time complexity. Okay, so now the main approach of the sliding window comes. Okay, because as we discussed in the earlier video, whenever we have a question related to this subarray type, in case of arrays, and we have to do some operation like deleting one element, and we have to find the size of the longest subarray, so this involves generally sliding window and 2 pointers. Okay, so now we will go for the sliding window approach. So this is a similar approach that I have discussed in the earlier video of max consecutive ones, and similar approach we'll use here. So max consecutive ones 3, I've created a video previously, so you can watch it on my YouTube channel in this playlist. Okay, so let's just write our example again. Array equals to 0, 1, 1, 1, then again 0, then 2 times 1, then again 1, 0, then 1. Okay, so in this question, in this earlier question, we have a k, in this question we can like update these zeros to 1 of k size. Okay, so if the k is 3, then we can update maximum 3 zeros to 1, flip them, and then we can find our maximum like number of consecutive ones. So this is similar approach, but in this question what we have, we are mentioned that we can delete only one element. Okay, that means, what means that when there is 1 0, we can remove it. Now we have to find our maximum consecutive one size. Okay, so what we can use in this approach from previous question, we can basically have k equals to 1. Okay, because in earlier we can flip it, now we just have to delete. So if we use k equals to 1, now what we can do, k is equals to 1 mentioned, so we'll have two pointers, right? So let's just have I here. Okay, I here and j here, right? So what was the approach? Whenever 0 comes, we will decrement k. Okay, so this is 0, so what I will do, it will decrement it to 0. I will move forward. Now 1, no operation. Now 1, no operation. Now 1, no operation. Okay, again I comes to 0. So when it comes to 0, what I will do, it will again reduce k to negative. Okay, and it will move. Okay, it will be here only now. Now what we'll check, so the other operation that mentioned is, if k is less than 0, that means we move our window using j. Okay, now what it means, that we till now at this point, okay, at this point we have found our window, we have find our window, okay, which is of the size, like max size, with which we can do this operation that is mentioned, that we can have 1 0 as mentioned. Okay, because it is mentioned that we can only delete 1 0 and find our size. So till now we have found our this max window size. So again when I comes to here, okay, when I comes to here, it means that it reduces this to negative, that means we need to move j again. Okay, j will move. Okay, since j was at 0 earlier, so j will, what will do, j again will update k, because j was earlier at 0, so we'll have a check. If j was at 0, j will move afterwards and update k, so that it means that in the current window, in new updated window, from here till here we have only 1 0, because if more than 1 comes, we will move our window. That what has happened now. Okay, now again I will come here, no 0. I will come here, no 0. I will again come here. Now it means that again 1 0 came, k will reduce to -1. It means that j will come to know that I has been reduced, so j will move afterwards. Okay, now I will move forward and j will move forward. J will only j will only stop until I k is 0 or greater than 0. Okay, so since current j I sorry k is -1, so j will move, because it means that in the current window we have a size, we in the current window we have more than two zeros, sorry, more than 1 0, more than 1 0 in the current window. Because if we can see in this window, if you see in this current window, what we have two zeros, right? That means we cannot use it as an answer, right? So j will come here. Now I will go beyond this, and yeah, so the current size will be I minus j, so it was like 5 size. Okay, and sorry, so it is 6 size. Okay, and since we need to remove one element, what we'll do, we'll subtract 1 and we will have our answer as 5. Because in the earlier question, this question, we just need to flip it, but in current question we need to delete that one element that we are using. So in this window, as we have seen, when we have only 1 0, what we need to do, we need to remove it. So this size was maximum 3 plus 6, Now we just need to delete one, that is 5. So we got our answer. So I'll like again have one example to better understand it. Small one, 1 1 1 0 0 1. Okay. Now we will place I and j here, and our k is 1. Right. Now we'll do current I is at 1. No need to do, just go forward. Similar now. I will come to first 0. Now it will do, when it comes to 0, it will reduce k2 by 1. Okay. Now j will check. J will check if k is less than 0. Okay. Since it is not, j will not move. I will again come to here. Okay, now k is less than 0. Okay, now j will check if k is less than 0. Yes, j will move, because as I've said, at this point this was our max size. Okay, and when I move forward, j also need to move forward to maintain this size. Okay, so j will check if yes, j will move. Again I will move. Again j will move. Now again I will move and it will stop. So we have our size as this 4. Okay, I minus j is 4, and we need to remove that one element, so we'll subtract 1 and we have our answer as 3. As we have seen, this was our window. Okay, this was our window. Okay, and we can, if we remove this, so this was our size 3. Right, so I think we got the approach, and the pseudocode for this approach will be, pseudocode will be a very simple one. So we will have our int I at 0, j will be at 0, and 1 k which is set as 1. Okay, now we'll just go for I. Okay, we can use some other names. Okay, sorry. So we'll use while loop. Okay, int I 0, j 0. So while I less than n, what we'll do, we'll check if a of I equals to 0. That means that we have encountered 0, so we'll need to reduce k minus minus. Okay, now what we'll do, if k is less than 0, that means the 1 0 we have already done removing, and one more 0 has come. That means we have to move our window. So we'll check if array of j is equals to 0. If j was at 0, that means that it will if we remove it from our current window, then we can find our answer. So we will then also we need to update our k. So we'll do, if a of j is 0, we will update our k, else we just move our j. Okay, so this is the while loop, and after that we will, what will return. So the window size was I minus j, and since we need to subtract one element, we will subtract 1 from it, we'll get our answer. And in this approach, the time complexity is big of n, since we are just having one while loop, and space complexity is big of 1, since we are just using these variables, not any data structure. Yeah, so let's just move to the coding part to better understand the approach. Okay, yeah, so what we'll do, we will have the size, the variable, yeah, then we will have our I, j and k. K will be 1 in this case. Now we'll do I less than n. Now if a of I equals to 0, that means that means we have encountered the required element need to be removed. That need to be removed. Okay, now we reduce K. Okay, now we'll check if K is less than 0. That means we have more than one element in our window. Okay, so what we'll do, we'll check if A of j is equals to 0, we need to update K. So it means if A j is equals to 0, that means we will remove this element from our window and update current elements in our window. Okay, right? And now we will move j. Once we come out of the loop, what will return? I minus j minus 1. Okay, so I minus j is window size, and removing 1 is required as per question. Okay, so we'll try to submit it. Okay, so we will update it to nums. Okay, yeah, we forgot to update the I. Yeah, yeah, so it is working fine for this run for all example test cases. It is working fine for all of them. Let's just try to submit it. Yeah, so it is working fine for all of the test cases. Thanks everyone for watching. In case you do like this video, please do subscribe our channel, and we will try to complete this Leetcode 75 days playlist together. And in case you have any questions, please do ask in the comment section. I will try to answer all of them. Thanks everyone.